So the diagraph's easier than actually listing the points. 1, 2, 3, 4. So 4 would point to 4, and then everything less than 4. 3 would point to 3, and everything less than 3. 2 would point to 2, and 1, and 1 would point to 1. So if you list R, you have to list all the points. 1, 1, 2, 1, 2, 2, etc. List all the arcs. No, it doesn't work for you. You have to actually list them all. If you can do the diagraph though, then you should be able to list R, right? So it just got to match the diagraph. Even if you get the diagraph wrong, you should be able to get that one right. Just have that one match your diagraph. So I'm going to be grading that based on your diagram. Is it symmetric? Symmetric?
No.
No. 2 points to 1, 1 doesn't point to 2. Okay. Is it reflexive? We'll skip transit for a second. Reflexive?
Yes.
Yes, everything points back. This was really bad for domain and range. You're not going to have one like this. Where the domain is everything and the range is everything, right? So,
What's the domain mean?
domain is what's pointing to something. The domain is the x values,
Oh, okay.
and the range is the y values.
Would you have to list multiple ones, like one?
Since it's a set, you just list it once.
Okay.
Is this transitive? Yeah, 4 points to 3, so it needs to point to everything 3 points to. 3 points to 2, 4 points to 2. 3 points to 1, 4 points to 1. So it is symmetric, transitive, reflexive. Is it equivalence relation?
No.
No.
Wait. It's not symmetric, it is transitive, reflexive, so it's not equivalent relation. If it was yes, 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 then that would be yes. And the main is what's pointing to something. The main is 1, 2, 3, 4, and the range is 1, 2, 3, 4.
Here's a question. So this is not transitive?
This is
Not sir.
transitive. It is yes. It is reflexive, yes, and then it's not symmetric. So 1C is no.
To be symmetric, you would have to have, like on the 2, 1, have 1 pointing to 2, and then like 2 pointing back to 3. That
Yeah.
kind of deal.
You can do this very easy in the bonus question.
No, that's going to be a little different this time. It's different every year. They just had the luck of their all, and this problem's a little easier for them, right?
Can you get a look at the drawing?
On some of them you will, on some of them you won't, right? So it balances out.
On G, you said the range is just the second number in the list? G.
The range is the secondary, so let's suppose we had this. Okay.
One's pointing to 3 twice.
No.
Just asking.
Okay. Is this reflexive?
No.
Nope. 3 doesn't point to 3. Is it symmetric?
Yes.
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 Mhm.
No problem. So it is symmetric. It's not reflexive. Is it transitive?
No.
No.
Yes.
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 1 points to 3.
But one doesn't point to 2. So
3 points to 2. 1 doesn't point to 2.
no.
So the answer is no.
It's not.
So it's not equivalence relation. If you had to list R, what would R be? Let's see. 1, 3, 3, 1, 3, 2, 2, 3,
2, 2.
2, 2. I've been known to give a problem like this and say add the minimum number of edges to make it reflexive. What would the minimum number of edges to make this thing reflexive be?
Arrow point. One to itself and 3 to
1 to itself and 3 to itself.
Did you say arrows or edges?
Edges technically don't have a direction, so these are technically arcs. This is why this is called a digraph. If it was just a graph, which you're going to see later, there is no arcs, it's just edges. A digraph is a directional graph. In math courses, if they have this, these are called nodes. And if there are no edges, it's called vertices. But in computing, we just call it nodes all the time.
Could you explain one more time why that's not transitive?
It's not transitive because 1 points to 3. So it needs to point to everything that 3 points to. So, no, what's the domain of this?
1, 2, 3.
1, 2, 3. That's the x values, right? And the range?
1, 2, 3.
1, 2, 3, yeah. I'm trying to create a problem more. It wasn't the same every time.
Good try.
Yeah.
Now
I suck at that.
Now I think that every time it's going to be
I know.
all the
Okay.
numbers.
Now I've got to put one on the test just to give you a graph so you can do the domain range. What's the domain of this? Domain? 1. What's the range?
Yeah, you should definitely put that one. It's a great example of a test question.
Okay, any other questions about that? Yes.
Yes, so just a quick refresher, how is the domain and range found?
The domain is the x values. So on this, the x values are 1, 3, 3, 2, and 2. So you just have to list them once. The range is the y values. So if you're looking at the graph, the domain is what's pointing to stuff. The domain is what's pointing to something. And the range is what's being pointed at.
Awesome, thank you.
Any other questions on that? Okay, so I could give you problems like the homework where if, let's see, A divides B, then it's reflexive. If A mod B equals 2, then A is related to B. Things like that. I put those on past tests. Just some sort of function where it's related if something happens.
It's the remainder. A mod B is the remainder.
Yeah. Isn't that on the other test? Let me pull up the other test real quick.
Yeah, there were mock questions I heard it there.
This one is A related to B if and only if A plus B is less than 7. So there's a few examples. Okay. So on to the next one. Already the probability, huh? Given a deck of 52 cards, how many possible 5-card hands are there? 52 choose 5. So this was supposed to be a warm-up problem, just like a gift.
You should please leave that.
I like this.
So you got that one wrong. If they got that one wrong, there, that's that one wrong. What's the probability of having 3 jacks? So you need 3 jacks. And that means these other 2 cards aren't jacks, right? And they also wouldn't be the same kind. Because if you had a queen and a queen, what would that be? Full house. So you have 3 jacks. How many ways can you have 3 jacks? 4. You have 4 jacks, right? Choose 3 of those. That gives you the 3 jacks. And how do you get those other cards? If you did 48 choose 2, then those 2 cards could be related, right? 2 queens. And if you have 3 jacks,
I mean, it doesn't say that
It
you
doesn't
can't.
specify that that's all.
I know. I actually gave credit to both on this. But if you have 3 jacks, If it was a full house, it would have said, what's the probability that you have a full house with 3
Oh,
jacks?
you're wanting a three of a kind.
3 of a kind, this 3 of a kind jack.
Okay.
So I actually get credit for both on this one, because it wasn't as so, what if it was 3 of a kind, so that means these 2 cards aren't related. 2 ways to do it. You can say 48 choose 1, and that gives you this card. You did 48 because you can't use a jack, right? Okay, so there's 4 jacks you can't use.
And that would be.
That gives you 1 card, and what's this next one?
47 choose.
Can't use 47 because you can be related.
40,
44 choose 1.
Is that times or plus?
This would be
Oh,
fine.
because another guy.
But the way I like to look at it is you choose the jacks, and then you need another card. So pick a different kind, and then take 1 card from that kind. That gives you the next card. And then pick a different kind, and then pick a card from that kind. That gives you 2 different bloodly kinds than jacks. That's exactly what this is doing. That 12 times 4 is 48. So you're picking 1 card that's not a jack, and here you're picking 1 card that's not what that card is, and then not a jack. And then you have to divide it by 52 choose 5. What's the probability of being dealt a hand of spades? You know, if you want some points and you have no clue, then at least you could say over 52 choose 5, right? I might give you a point for that. Okay, so
Me too.
I'm not the grader, I do give partial credit.
Thank you.
It's my grade on test. Okay, and what's the top?
Was it hand of all 5 spades?
All 5 spades.
So it would be 13 choose.
13 spades, choose 5.
Yeah.
13 choose 5.
I was just gonna 55 and 52.
Okay, the bin problem. You have 15 balls, 10 black, 5 red. What's the probability that you're picking 6? How many ways can 6 be chosen so that 4 are red?
so 5, choose 4.
Okay, you need 4 red. So you have 5, choose 4.
15 choose.
Oh, and then you gotta do the
10
rest.
choose 1, then
Do the
times
rest
10,
of them.
times 10 choose 1.
Oh, yeah.
6.
You have 4 red, how many black? 2 black. How many you have to pick from?
10 times 10 choose. Oh, I don't know why I said 10.
Choose the 4 red from the 10, from the, 5. Choose the 2 black from the 10. That gives you 4 red and 2 black. That gives you 6 balls.
And then over 50, over.
I didn't ask for probability, right? So this one's asking for the probability. So this one would be 5 choose 4 times 10 choose 2 over what? What's the total number of outcomes?
15. choose
15 choose 6. Okay, you just put that right off, right? Okay, that's 3A. That's the probability of 3A. Okay, what about B? How many ways can 6 be chosen so that all 6 are black? 10 choose 6. There are no other ones to pick. So the probability would be 10 choose 6 over 15 choose 6. What if I said at least? Let's say at least 5 black. At least 5 black. Then what would that be?
You go here.
If it's at least 5, how many does it have?
10 choose 5.
10 choose.
How many black?
We get that back.
Altogether.
You have 6 balls. How many black can you have?
5 or 6.
5 or 6. So if you have 6, you know how many options there are, right?
10 choose 6 times 10 choose 5.
10 potentially 5 times.
We'll send